this is Mrs. Tellas. We're going to be solving equations like we have been, but now we're going to have variables or letters on both sides of the equal sign. This is section 1.3. All right, the objective is always when you're solving equations to get the x all by itself. Okay, so I want to get the x alone on one side, whether it's in the front or the back, doesn't matter, just has to be by itself. So if you would like to push pause and write these steps down, these are the steps we will be taking to solve these equations that have variables on both sides. So if it has a parenthesis, you'll use your distributive property first. If you have combined like terms on both sides, on either side, so if you have an x and an x on the left or an x and an x on the right, you have to combine them. Or if you have constants on the right, got to combine them, or on the left, got to combine them. Then it will be a two-step. Actually, not yet. Then we will move the smaller variable term to the bigger variable term by adding or subtracting. We'll do the same thing with the constant. When we get to right here, this is a two-step now. We know how to do these really well. And then last, you either multiply or divide the coefficient. Usually we divide it. And then you can check your solution by plugging it back in. So if you want to write these down, push pause and write down your steps. If you don't, that's okay. All right, so this one right here. So I remember I want to get x by itself, but notice it's got two terms on this side and only one term over here. It's got an x and an x. So I need to move this term, this negative 4x, to the other side because I need it to all the x's to be on one side. So usually I move the smaller one, but in this case, this is the smaller one. But if I move this one over here, then everything will be on the left, and I don't want that. So I'm going to add 4x here and here. So those cross out, and the 10 just drops down. And over here we have negative 5x. Now it's just in one step, so I'm going to divide by negative 5, and my answer is negative 2. Okay, so I want you to push pause and try number 2. Okay, it's really the same thing. Okay, give it a pause and try it. All right, so I'm going to move this negative 2x to the right side with the 10x because the 10x is already over there by itself. So I'm going to add 2x to both sides. The 6 is going to drop down. And this is 12x on this side. And I divide both sides by 12 because that's what's next to the x, and that's what I want to cross out. And I end up with 1/2, or you could also put this as 0.5. Okay? Hope you got that right. All right, and number 3. Number 3, if you notice, it's got 1, 2, 3, 4 terms, 2 on each side. Okay, notice it's got an x on the left and an x on the right. So this is where I use the rule. I take the smaller x to the bigger x by adding or subtracting. So negative 8x is smaller than negative 6x. So I'm going to add 8x to both sides. Those cross out, the 2 drops, and this would be 2x, and the negative 14 drops. Okay, now it's just a two-step. So I'm going to take this constant and move it over here by adding. That drops down, and that crosses out. And then I can divide by 2. So my answer is 8. Okay, so step 1, I added 8x because I wanted to move this negative 8x to the other side. Step 2, I added 14. And step 3, I divided by 2. Okay, let's look at number 3. Actually, number 4. Number 4 is different because it's got multiply or grouping symbols in it. Do you notice the grouping symbols? This means that we have to use what property? Do you remember? I hope you said distributive. So we're going to distribute the 3 here and here, which means we're going to multiply. So 3 times 3x is 9x, and 3 times negative 4 is negative 12. Okay, and you can use your calculator if you want to get the signs right. That's totally fine. Desmos, or if you have a handheld. Then I'm going to do 1/4 times 32x. That is 8x. And 1/4 times 56. That is, let's see, 56 divide, 1 goes in, 1 left over, 14. Okay, and again, feel free to use your calculator. Desmos does fractions. Okay, now notice I've got 1, 2 on this side, 1, 2 on this side. So I'm going to move the smaller x to the bigger x. I'm going to subtract 8x. That leaves me with 1x here. This negative 12 drops down. Those cancel, and the 14 drops down. Now I need to move the negative 12 to the right. So I'm going to add 12 because the opposite of minus 12 is plus 12. So 1x drops down. The 12s cancel, and this is 26. I can divide by 1 here, and I end up with x is 26. Okay, and I could take the 26 and plug it back in, check it, and see if it's right. So although it looked terrible because it had parentheses on both sides and it had a fraction, okay, we have a calculator. We're not afraid of fractions because we have a calculator, and we know how to distribute. All right, go ahead if you'd like to push pause and try number 5 and 6 on your own and see if you can get them. Okay, this would be a really good practice time for you, 5 and 6. And then I'll come behind you when you push play again and I'll do them for you. So I want to subtract 3x on both sides because there's only one x over here. If I move plus 2x, then everything's on the right. And I can't divide because there's nothing over here on the left. So I want that x on that side. So that's negative 5x equals 10. And I divide negative 5 and I get negative 2. I hope you got that right. If you did, give yourself a pat on the back. And then 1/2 times 6h would be 3h. And 1/2 times negative 4 would be negative 2. And I'm just dropping this down. Okay, I'm going to take the smaller h to the bigger one. So I'm going to add 5h to both sides. So this is 8h minus 2, and it equals 1. This one's going to be a fraction. And then we need to add 2 to both sides. So I don't have any room, so I'm going up here. So 8h on the left because those cancel, and then 3 on the right. Then I can divide by 3. Now I can put this in as 3 divided by 8 in my calculator, or I can just leave it as 3/8, and I'm just going to leave it. I hope you got that right. If you did put it in as a division problem, 3 divided by 8 is 0.375. So that's also a correct answer. Okay, so this is where it gets different than before. So all of the ones we just did had answers. They have a specific number that could go in for x that makes it true. But some equations don't have just one answer. And sometimes the variables completely cancel out. And when they do, you have to look and see what's left and see if it's true or false. Okay, press pause and write this down, and then we'll do a couple and you'll get the hang of it. So a true statement, so like if the x's cancel and you end up with 2 equals 2. Well, that's true. And if it's a true statement, you write infinitely many solutions. And we're going to abbreviate this IMS. Infinitely many solutions. Okay, and if the variables cancel again and we get a false statement like 1 equals 5. Well, 1 does not equal 5. That's false. So then our answer is no solution. And you can abbreviate that too as no solution NS. Okay? All right, so let's make sense of what we just wrote down. Hopefully you pressed pause and you wrote that down because that's going to be important. All right, so here we go. We've got a parenthesis. That means I have to do what property? I hope you're thinking distributive property. So 3 times 5x is 15x, and 3 times 2 is positive 6. And the 15x on the right just drops down. Notice there's only one 15x over here, so I'm going to subtract it on both sides. Notice they both cancel. So I have 6 equals nothing. Well, the number for nothing is 0. Does 6 equal 0? No, 6 equals 6 and 0 equals 0. Those are not true. That's a false statement. So this is no solution. And what that means is that there is no number that you can put in here for x and it will make it true. Okay, there's no number that will work. And that's why the answer is no solution. So you know it's no solution or infinitely many when your x's cancel. You look to see what's left. Okay, let's do this other one. Again, I have grouping symbols, so I'm going to distribute the negative 2. That's negative 8y minus 2. And on the other side, I have the same thing. All I did was drop those down. Okay, so I'm going to add 8y to both sides. And I hope you're noticing that they're exactly the same on the left and right. See how the negative 2 drops and the negative 2 drops? Well, that's true. Negative 2 does equal negative 2. So since this is true, I write infinitely many solutions. That's my answer. That means I could put any number in here for y as long as I put the same number in both places, and it will make it a true statement. That's what it means. So you only have those when your x's cancel. Then you look at the constants to see if it's true or false. All right, your turn. You try, pick 2 out of 3 and try them. stop the program, stop the Screencastify, the video, and try 2. And then I'll do 3 of them and you can see if you're right. Okay? Go ahead and pause. All right, number 10. So I'm going to distribute because it's a parenthesis. So 4 minus 4p equals negative 4p plus 4. Okay, and all I did was drop those straight down. Okay, so I'm going to add 4p on both sides. And both sides cancel. And I'm left with 4 on the left, and I'm left with 4 on the right. That's true. So I write infinitely many solutions. I hope you got that right. Here I've got a distributive property problem again. So that'd be 5m, use your calculator, minus, let's see, 50 over 6, because 5 times 10, let's see, 50 over 6 can be 25 over 3. So 25 over 3, and then equals, that's just 5m because there's a 1 there, 6m minus 1m. All I did was combine like terms there. Okay, so if I subtract 5m on both sides, there's nothing over here. The number for nothing is 0. And then over here I have this weird little improper fraction. Well, that's not true. So this is no solution. 0 doesn't equal the weird little fraction. Okay, so I hope you got no solution there. And then on number 12, if you chose number 12, which I probably would have because I would have probably stayed away from the fraction. Okay, so here I would add 10k to both sides. That's 20k plus 7 equals negative 3. Those crossed out, but those did not because I was adding them. The 7 dropped, and so the negative 3. Then I'm subtracting 7, and I get 20k equals negative 10. I divide by 20, and I get negative 1/2, or negative 0.5. Excuse me. And that's your answer. The answer is negative 1/2. This has an answer. See how the x's did not cross out? Or in this case, it's the k's. But they didn't cross out. So since they didn't cross out, it's just a normal answer. It has a number you can put in. Okay, I'm all finished. I want you to give the Big Ideas assignment a try. If you have questions, email me or go to the conference in Canvas, and we can do a few of them together. Okay, have a wonderful day. See you later.